Welcome to Scaling Up H2O, the podcast where we celebrate Industrial Water Week, the official podcast for water treaters everywhere to celebrate Industrial Water Week 2022, the fifth time we have celebrated Industrial Water Week. And happy Boiler Tuesday, everybody. If you didn't know, we are celebrating Industrial Water Week all this week. When is Industrial Water Week? It's always the first full week of October, and we start out Mondays by celebrating pre-treatment. Boilers like today on Tuesday, we celebrate, and then Cooling Wednesday, Wastewater Thursday, and Careers Friday. An entire week for us industrial water treaters to celebrate this fantastic, this noble profession that we all love. On an Industrial Water Week episode in the past, it was a Boiler Tuesday episode, I shared the story of a laundry I used to take care of. And in that laundry were two Cleaver Brooks boilers, and they were named Thelma and Louise. There was a boiler operator there that was an amazing woodworker, and he carved these two beautiful plaques to name these boilers Thelma and Louise. Now, I wish I had a picture of these plaques. These weren't just carvings. They were embellished. They were beautiful. And the funny thing is I know that gentleman worked so hard to make those beautiful plaques to display the names of those two boilers. The funny thing is they hardly did any of my recommendations in that plant. And I couldn't help but think, if you spent a quarter of the time doing the recommendations that we recommend versus all the time you spent just making those plaques, this would probably be the best boiler plant in my entire portfolio. I shared that a couple of years ago, and so many people had similar stories. How do I know that? Because they hashtagged them to IWW22 and hashtag scaling up H2O. So if you have a story about a boiler, I want to hear about it. The nation wants to hear about it. Your brothers and sisters in water treatment want to hear about it because that's how we celebrate Industrial Water Week. We share stories through social media. That's hashtag IWW22 and hashtag scaling up H2O. And by the way, thank you to all the people that shared their post for Pre-Treatment Monday. We've got lots of opportunities for you to share. And Nation, the reason I bring it up is because that is my favorite way to celebrate Industrial Water Week. I want to do it with the community. That is you. And trust me, you will enjoy celebrating that way too if you're not already enjoying this. As I always say, this industry is so much more fun when you share it with others. Speaking of sharing, each and every episode this week, we are conducting mini interviews about the themes of that particular day. Today, we have one on boilers. Our goal with these mini episodes is to give you something shareable with the people you want to educate. Now, maybe it's a customer. Maybe it's a new or potential employee. Maybe it's your mom. You get to figure that part out. We want to make sure you have something so you can share because we feel that's how we make the industry better. When people understand our industry better, it just gets better. Speaking of somebody that is really helping educate people all over the world about industrial water treatment, here's James McDonald.
Hello, Scaling Up Nation. Happy Industrial Water Week. As we celebrate Boiler Tuesday, I am reminded of the importance of using all of your senses to assess a water system before you get started. This includes sight, hearing, smell, touch, and if you can figure out how to use taste, more power to you. A customer had a blowdown flash tank that drained to a floor drain below it. The floor drain was clogged, so the blowdown would overflow across the floor to another nearby drain. This was just something you got used to until the next shutdown when the drain was scheduled to be unclogged. One day I came in to service the account and used 2 senses at once to ascertain the situation. I both slipped upon and saw a brownish slime on the floor. It takes years of advanced training to reach this level of diagnostic ability, let me tell you. This brownish slime could have had a few possible causes. First, hard water softeners. Since they were using a phosphate-based boiler treatment program, calcium making it past the softeners would form calcium phosphate and be dispersed with the polymers. The brownish sludge could have been the calcium phosphate and polymer sludge forming in the fire tube boilers. Second, process contamination. The sludge could have been a result of process contamination that was returned with the condensate. However, knowing the customer's processes, I could think of nothing that would react in this way. Third, corrosion byproducts. If a lot of iron is being returned due to condensate system corrosion, it would form a similar phosphate polymer sludge. Condensate system corrosion had never been an issue with pHs usually being on the high side instead of the low side. The cause of the brown sludge ended up being hard water softeners. The water softeners had malfunctioned and hard water was going to the boilers. I regenerated the softeners and had them increase blowdown and chemical feed to the boilers. The softeners were fixed as well. The responsibility for testing the boilers had recently been changed to another of the customer's maintenance employees. This person was not checking to see if the softeners were producing soft water. All they knew was that the boiler water was much browner than usual and it was hard to keep a phosphate residual. They never asked anyone why this was happening. This ended up being a lesson to the new person. Luckily, I caught the incident before too much damage was done, and the boilers opened up only slightly dirtier on the next inspection. I like this story because it reminds me of the importance of using your senses not only to diagnose a problem, but to be safe as well. Luckily, I wasn't hurt when I slipped, but it was a lesson to be far more careful the next time I stepped onto a wet floor. I also like the lesson on effective communication between operators and with you, the industrial water treatment professional. I hope you enjoyed today's story on water and equally hope you will share one of your own on social media to help celebrate Boiler Tuesday of Industrial Water Week. Don't forget to tag them with hashtag IWW22 and hashtag ScalingUpH2O.
So James is challenging us to do water treatment via our senses: sight, hearing, smell, touch, and the challenge was taste. Nation, please be very careful with this one, but I can't help telling you I have a taste story. When I was a very young chemist working at another company in their lab, I got the experience to use taste. Well, sort of. I was a chemist in the lab, and I got a phone call from a representative that was in Florida, and he was complaining about a particular product that we had. It was a cooling tower product, and something was off. Now, me being relatively new in the industry and wanting to prove myself, I didn't ask any questions. I took it for face value. Something was wrong. I got the Retain sample number from the lot number, and I pulled the Retain and I ran all the tests like a good chemist should. Couldn't find anything wrong with it. I then called the gentleman back and reported to him that everything was as it should be. And then I asked the question that I should have asked in the beginning, that I would have saved 2 hours of work by asking that question. And the gentleman proceeded to tell me what was wrong with the product. And what do you think it was he said was wrong with the product? Yes, you guessed it. He said it just didn't taste right. Apparently, This gentleman would stick his finger after opening the bung of every drum that he would have and taste it. And he said it did not taste right. Nation, you cannot make this stuff up. I encouraged him to stop that procedure. It was not good for anybody. And Nation, taste, I'm going to give it to James. I don't know really how you can use that safely, but if you can, I'd love to hear about it. I would love for you to hashtag that story to Scaling Up H2O and IWW22. Well, each and every day this week, we're also asking people what they wish they knew when they first started in this industry. Now, I sure wish I knew to ask people if they were tasting products, but whoever knew that? One of my favorite stories about what they wish they knew when they first started comes from my mentor, Bruce Ketrick Sr., and this is a story you might have heard if you have taken his boiler class. He doesn't tell it much anymore, but he used to tell it every time he was talking about boilers. So this is a story about why you don't want to rush and what happens when you rush and what happens when you have a Scottish engineer questioning why you rushed.
I was sent out to clean the water softeners at Anaconda Copper in Perth Amboy, New Jersey. These were old Permuted units with the old black base plates, and the resin was dirty. And so what you do is you pull the heads off, you put air lengths into the bottom, you add your resin cleaner, which is basically citric and a phosphonic acid, and you slowly agitate to make sure that it cleans. Being in my early 20s, and this being on a Friday, and me wanting to get out and spend time with my friends in the bar, I thought that I could quicken up the entire cleaning process by turning up the air. Unfortunately, the way you tell you have soft water is by shaking the water with some soap at that time, and it creates a tremendous amount of foam. Everything was going well. I walked out, went to get a cup of coffee, came back, and the plant engineer was standing there looking in the window into this softer room, just looking. And I went, "Chief," and John Greer said, "Well, Bruce, about how high do you want to get the foam before you're done?" I had filled the room with foam. So, needless to say, you shut down, you wash it all out with a hose, you start all over, you're scared to death. Sometime around Saturday night, I got done. And he came in and inspected it, and looked at it, was very pleased, and then looked around the room and he said, "Well, you've cleaned the walls from here on down. What about here on?" Because everywhere the foam touched, clean the epoxy paint down to like brand new paint. You don't realize how dirty a room is till you clean the paint below it. And foam does not make a straight line. So Sunday morning, after I got done cleaning the rest of the walls, I got to go home. That was my first introduction to being out of the lab in a facility. I don't recommend sleeping in a copper plant.
Nation, again, one of my favorite stories that he tells, and I think one of the reasons it's my favorite story is I have almost an identical story, and this comes with I didn't do what my father told me to do. Now, if you've listened to this podcast for any length of time, you know I wound up in this industry because my father, Ray Blackmore, was an industrial water treater, and he taught me the craft. And when I first started out in this industry, my dad was a really good teacher, but I was a typical son, and just because my dad told me something, I always thought I could do it better. Of course, I lacked the experience my father had, but I don't think sons realize that at the time that they are acting on whatever they are acting on. So just like Bruce, I had to clean a series of water softeners. They were fouled. So I opened all of them up, and my dad gave me specific instructions. He told me how to make the air lance. And if you're wondering, that's just a PVC stick with a bunch of holes in it. And you put an air valve on the top of it so you can hook that up to an air compressor. And you just trickle a little bit of air in to agitate all of the resin in the tank. And then, of course, you put cleaner in there. Well, here's what I did. I had a bunch of cleaner left over, and I figured, well, my dad only told me to put this much. Surely 10 times the amount's going to be better, and I don't want to carry that stuff back. It's heavy. So I put so much more cleaner than my father told me to put in there. And instead of just trickling the airflow through that PVC lance, I really put the spurs to it. And everything was fine. And of course, since everything was fine, I went back to my car to start putting some things away and carry some other things out to get ready. Well, I didn't have the entire mechanical room full of foam, but it was about 3+ feet of foam everywhere, the entire mechanical room. And why didn't I get more foam? Why didn't it foam all the way up to the top like in Bruce? Well, that's how much foam you get when you walk away to go to your car. That's scientific proof of that. And luckily, instead of having to clean the walls were relatively clean, and we didn't really see anything on the walls. But we had a bunch of equipment in there, like the boiler, that it was just cleaned on the bottom quarter, and they did not like how the bottom was just cleaned, so they had me go ahead and wipe down everything else. Anyway, it was a mess. It took forever to clean up all that foam. I'm so fortunate that we did not short out any electrical equipment. I, for the life of me, don't know how that didn't happen, but it didn't. And I was there the entire day hosing and spraying defoamer and wiping down equipment. Nation, fast in water treatment is always slow. I'm curious what story you have that you want to share. Don't keep that to yourself. Share it on social media by hashtagging IWW22 and scaling up H2O. Well, Nation, as I mentioned, each and every day this week, we're celebrating Industrial Water Week by doing a mini interview on the theme of the day. And today, here's our interview on boilers. My lab partner today is Chuck Hamrick Jr. of Eagle Consulting. Chuck, so good to have you on this Industrial Water Week Boiler Tuesday. How are you?
I'm doing great, Trace. Thank you for having me.
Absolutely. I really want to say thank you for celebrating Industrial Water Week with us. And of course, we're going to be talking a little bit about boilers today. But I have to ask, how are you celebrating Industrial Water Week?
Well, I'm looking forward to seeing everything that goes on. I plan on sending some pictures throughout the week for the different things, such as cooling and boilers and pre-treatment and so forth. So I'll probably be in the office most of that week and just been boning up on some of the stuff I need to learn and just looking forward to hearing what everybody else has to say that week.
Well, awesome. I look forward to seeing those pictures that you share. Chuck, I was hoping that we could talk at a very high level, so maybe a 30,000-foot view of boilers and water treatment. Are you game?
Sure, let's do it.
So if I was just starting in water treatment this week and my boss said, I want you to go out there and I want you to look at this boiler, what would I be looking at?
I'd definitely be looking to make sure that the valves work. I would also be looking at all the pre-treatment equipment to verify that it works, that I'm getting good soft water or RO water, depending on what the boiler makeup type would be. I would be making sure that each and every one of the different chemicals that I'm putting in, be it a sulfite treatment for taking control of oxygen in the boiler, make sure the pumps are primed and working correctly and there's no leaks, making sure the tank for the polymer is correct and the dosage rates are being done right, and just making sure the low water cutoff would work when I open up the valve to verify that it would keep the boiler safe. I think those would be some of the main things I would do, Trace.
Chuck, let me ask, if I was standing in front of a boiler, how would I know if it was a fire tube or a water tube?
Well, that's a great question. I think a lot of people, especially the first week or so that they're in there, they would not really know. But you would see the different pressure gauges that would be on the boiler, and you could see how the steam trap and the steam header look would be a very large indication on that. That's pretty much what I look for.
And how would you know if it wasn't a steam boiler at all? It was just a closed loop boiler.
Well, the difference between a steam header boiler is that the way the steam header is designed plus the pressure gauges on it. A hot water boiler would normally have a pump that you would see that would actually be circulating the hot water through the entire system and then back to the boiler and be reheated again.
Chuck, what would you say some of the problems are that we need to know about as a water treater so we can make sure that they don't happen?
Well, as I said, one of the most important things is to make sure the low water cutoff works, especially on a steam boiler, because if it's acting like it's staying up, meaning there's water in the boiler, and it's not actually reading right, meaning it's saying that the water is high or where it's supposed to be, but it's really low, you could cause a boiler explosion at that.
That's a bad day.
That's a really bad day.
I know a lot of people are always confused about priming. What exactly is that?
Priming is the violent action of the water in the boiler in which water droplets are carried away along with the steam. Some of the causes could be, like, number one would be like organic matter in the boiler water, suspended solids in the boiler water, like real high solids, maybe soap-like substance in a boiler. I know one of my large steel coaters have different baths that the steel goes through, and they have heat exchangers in there to heat it up. And if the heat exchanger goes bad, then the soap compound will come back to the boiler, and that causes a real mess. High alkalinity can do it. Operating boiler at steam pressure below the design pressure. Too high of water level in the boiler, which will encourage priming, especially with the load changes from low to high. When they're going from a low fire to high fire, and you have all that surface tension on the top of the boiler, it could carry out like a blanket and have water going throughout the system now.
Chuck, with priming, is that typically meaning the boiler is undersized for the load that it's demanded from?
Not necessarily, but it can be. As I mentioned, it's a lot of it, priming could be where you get some impurities coming back, process contamination maybe coming back from your process, as I mentioned, such as like oils, soaps, high alkalinity, and as you just mentioned, operating boiler at a steam pressure below the design pressure, too high of water level in the boiler, which will encourage priming, especially when the load changes from low to high.
Well, how about foaming? Why does a boiler foam?
Well, boiler water carryover is the main contamination of the steam with boiler water solids. If the bubbles or the froth actually build up on the surface of the boiler water and pass out with the steam. This is called foaming, and it's caused by very high concentration of solids in the boiler water. Maybe not blowing the boiler down properly or having a skin surface blow down. It is generally believed, however, that specific substances such as alkylus, oils, fats, greases, certain types of organic matter, and suspended solids are particularly conducive to foaming. In theory, suspended solids collect in the surface film surrounding the steam bubble and make it tougher. The steam bubble, therefore, resists breaking and builds up foam. It's believed that the finer the suspended solid or particle, the greater their collection in the bubble, which means they have a better chance to lift out of the boiler and head out towards the load and the process.
And that gets us to our really big problem that both the two areas we were just discussing lead us to, which is carryover. Why is carryover such an issue?
Well, it's because of the fact that the carryover contains a lot of boiler water solids, from the chemistries that we put in to the solids building up like calcium carbonate and calcium itself, magnesium, other things that come in with the makeup water, which then can go out into the steam header. And because then the steam is extremely hot, those particles come out of solution and form to the wall. And I've literally seen a 4-inch steam header that was had a lot of carryover taking place in this particular count, not mine, but went down from 4 inches down to an inch because of all the carryover that was taking place.
I always look at it that in addition to that, steam on its worst day is 1,150 BTUs, where water on its best day is 180 BTUs. So we don't want water in the steam. We want steam in the steam because that's what's doing the work for us. And a lot of times that can cause more priming or surging or all that stuff because we're actually we're getting what they call wet steam.
Very good point.
So with wet steam, have you found that there's a better determining factor that you are going to get wet steam than another?
Well, as we said, if our conductivities are too high, also if you got older boilers that the steam separator in them are getting quite brittle or non-existent in some cases, and seeing high conductivity readings coming back from your condensate would be a strong indication of carryover taking place, which, as you state, would be causing wet steam and not getting all the energy out of that steam that you wanted to get, but you're still using all the propane or coal or whatever your fuel usage is to be able to be used up inefficiently.
I know a lot of water treaters, especially if they're running phosphate programs, they want to run a higher alkalinity as an insurance policy, so to speak.
That's true.
Some people will see carryover and specifically wet steam or foaming, all of those, if they have too high of an alkalinity. What's your opinion on that?
Well, I don't know if there's an opinion on that for me because I've seen that happen. And, so I think, that's one of the important things. You need to watch over your conductivity. You need to make sure what your alkalines are to keep them in the best control range to prevent that carryover or priming or misting, as some people might say, because all those solids that go out in the steam line can cause you problems throughout the rest of the boiler system, even to the point of some of the crystals that are being formed, breaking loose, and eventually coming back to your feed water tank and then through your feed water pumps and shearing a lot of your impellers and your seals and so forth into your feed water pumps.
Chuck, there are some YouTube videos. I think you've seen them. Have you seen what Spirek Sarko did looking inside a boiler?
Well, in 42 years of 40 years in water treatment, I would say I probably have, but I might not remember what you're getting at.
I'll try to see if I can get those videos on our show notes page. But what Spirek Sarko did is they took each one of these issues and they replaced one of the flanges on the boiler with a piece of glass. And they videoed each one of these things so you can actually see happening everything that we're talking about here. You can actually see that foam building on each other. You can actually see what happens with the boiler slowing down when the feed water pump comes on and how the boiling stops and it has to work itself back up again. I'll see if I can get permission to put those on the show notes page. It's just cool that you can it's almost like you shrunk yourself down and you can look inside the boiler. It's very powerful to see those things because it brings them to life.
Oh, man, visual is one of the main things that people need to be able to understand and get things into their mind and be able to retain them for many years to come.
Chuck, you are one of the masters at selling water treatment. What is one of Chuck Hamrick Jr.'s tips on selling water treatment if somebody has a boiler?
Well, one, making sure you do everything thoroughly. We do a complete audit of a system before we even talk to someone about the boiler. We do get at Eagle Engineering, because of the long years that I've been in the business, we get a lot of recommendations and referrals. So that makes the selling a little easier. But we go through a step process of what we're going to do by doing a survey and then coming back with a thorough report and then answering a lot of their questions. We tend to ask more questions for the client to be able to answer so that they feel like they're a major part of it. And we just then try to befriend them, get to know them better, and leave it in the hands of the Lord for allowing the sales process to work to our advantage.
Chuck, thank you for coming on Scaling Up H2O and sharing Boiler Tuesday with us.
Thank you, Trace.
Scale Up Nation, Chuck Hamrick is one of the people that I first met when I got involved in leadership at the Association of Water Technologies, and he is just a tremendous individual. He is a member of the Rising Tide Mastermind, and he just shares so much with the group and gives so much good advice. If you do not have people in your arena that you can ask questions to, you're missing out. So I don't know if that's a mastermind. I don't know if that's a mentor. Whatever that means to you, life is too short to do it alone, and water treatment is just too darn hard to do it alone. You need to make sure that you have people in your life that make you better and you make them better. So I urge you to figure out what that means to you and act on it. And if something you need to act on is you did not get enough Chuck Hamrick today, well, don't worry. We just interviewed Chuck Hamrick on episode 271. So by all means, go listen to that and you can get more Chuck Hamrick. Scale Up Nation, I hope you are enjoying this 2022 installment of Industrial Water Week. I hope you are celebrating. I hope you're enjoying Boiler Tuesday. And I hope that you're enjoying every single new episode that we release this week. We do that as our gift to you to make sure that you have something to unwrap under the Industrial Water Week tree each and every day this week. And I hope you look at this industry as a gift. I know it's been a gift to me. Sometimes it's a gift I wish I would have kept the receipt on so I could have returned. But I have learned so much being an industrial water treater, and it's led me to so many wonderful experiences, so many wonderful people. It definitely is a gift. I hope you look at it this way, and I hope you also realize that one day you will have to take that gift and you will have to rewrap it and you will need to give it to somebody else. But it's not going to be the same gift. It's going to be embellished with all of your experiences. I can't wait until you give that gift to somebody else. Happy Boiler Tuesday, everybody. Here is an encore presentation of Detective H2O and the Case of the Standing.
Welcome to Detective H2O, the Case of Standing. The rain ran serpentine paths down the windows of the rusty blue Ford as Herbert Henry Oxidane, P.I., CWT, sat waiting on Johnny Keelan to open the side powerhouse door of Pork Belly's Processing. When the lanky man's shaggy head popped out, the water detective made a run for it, dodging raindrops best he could. Shaking buckets of water from his coat, Detective H2O said, "I'm here. So what's going on, Johnny? I got here as fast as my bald tires would slide me."
"Glad you made it, Detective H2O. These boilers aren't doing good right now. The connectivity is through the roof. Higher than my grandma that time she ate those special brownies."
"How high?"
"Well, she danced on the tables at the nursing home."
"Not your grandma, the boiler connectivities."
"They're over 10,000 microsiemens. The connectivity meter is pegged out."
Detective H2O whistled. "That is high. What's happening? Any idea?"
"None. But the RO permeate storage tank is at 1,500 microsiemens too. How's that possible? City water is only a few hundred microsiemens, and the RO drops it down to less than 10 typically. It's a real head-scratcher, this one is."
"And you don't feed any alkalinity booster or anything to the RO permeate storage tank, do you?"
"No, nothing like that."
"How about your dechlorination feed, upstream of the RO? Is it malfunctioning and grossly overfeeding?"
"No, I thought of that already. It has the same setting as always. I even watched and listened to the pump. Seemed the same as always as it pumped away. Checking the RO feedwater connectivity after the pre-filters was the same as always too. It's a mystery."
Don't you return condensate to this RO permeate storage tank too? I've always said you should rename this tank the RO permeate and condensate storage tank.
Yes, we do,
said Johnny as the thought slowly dawned upon him. Follow me, Johnny, said the water detective as he led the way through the maze of pipes and equipment. 5 minutes later, he stood in front of the condensate polishers. Picking up the water treatment log sheets, Detective H2O saw that Unit Number 2 had come online just a few hours ago.
What is it, Detective?
Can we put this unit into manual regeneration right now?
Yes, but it just came online this morning. It shouldn't be anywhere near time for a regeneration.
I realize that. Just humor me a little.
Okay, here goes. Unit Number 1 coming back online. Unit Number 2 going offline and starting the backwash sequence.
The water detective stood there beside Johnny, watching the regeneration water flow to the drain. The backwash stopped and the brine draw started. The brine level dropped as expected. Then the slow rinse step started. Aha! Exclaimed Detective H2O, uncharacteristically. Quick! Go get that connectivity meter you use. Johnny ran off quick as a whip and returned shortly after with a black analog connectivity meter.
What are we going to measure? There's no water coming out.
I know. That's just as I suspected. Just wait. Several minutes later, water flow to the drain started again as the fast rinse step started. Detective H2O took the connectivity meter and measured the fast rinse each minute for the 15 minutes of the rinse. That's it. Fix that valve right there. That'll fix your boiler connectivities.
Wait, what? Why that valve? How will that fix the boilers?
As you saw, no water was flowing during the slow rinse step. The valve must not be functioning properly. Since the condensate polisher did not go through a slow rinse, all the salt and any exchanged ions did not get rinsed out of the polishing vessel. Even though it went through a fast rinse step, the connectivity only got down to 3,000 microsiemens at the end of this regeneration. When Unit Number 2 comes back online, it will be feeding this high connectivity water straight to the RO permeate storage tank, with the next stop being the boiler system. We found our culprit.
Wow, Detective H2O, let me check out that slow rinse valve.
Sure enough, the valve was not functioning properly and was rebuilt. With increased blowdown and a little time, the boiler connectivities and RO permeate storage tank connectivity returned to normal. A week later, as Detective H2O was sitting at his oak desk, listening to the rain and thunder, his phone rang once, twice, 3 times before he answered. Detective H2O here, the best water treater this side of the Ohio, solving water problems drop by drop. What you got?
Detective, this is Marty Cochran down at Pork Belly's Processing. I've got a bone to pick with you. This bill you sent is outrageous. Johnny tells me you were here for only an hour, stood looking at one piece of equipment, took a few readings, and left. Why would you charge such an outrageous fee for only that?
Well, $10 of the bill was for the gas to get to your plant. See, my Ford is a little gas hungry. The rest isn't just for standing there, as he said. The rest is for knowing where to stand. You're welcome. In the underbelly and penthouses of the metropolis of Waterville, where the boilers percolate and cooling towers fog, there is one man who works tirelessly to end corrosion, stop scale, fight low-life microbes, and conserve water. That man is Detective H2O, best water treater this side of the Ohio, solving water problems drop by drop.